All right, so you should have just completed watching the FlowCab factors and prime numbers video. And so now we are going to be completing our video notes based on that, or our factors and prime number notes based on that video. So when we look at what a factor is, well, a factor is, like what the song gave, is a number that goes into another number evenly. Now, let's break down a couple of these words. So the word, or a couple of these words here, let's change that color, that goes into. So that means that we are dividing, that divides into another number evenly. And then this evenly part, that means that there are no remainders. And that's a big deal, no remainders to that. So let's look at a couple of these here. And a key concept here that I want to also stress is the idea that we are going to be doing what I call factor rainbows. Because a rainbow has these arcs, right? Well, we're going to be seeing a lot of factor rainbows as we break down our words, or break down our numbers as we find all the factors of them. So for 6, find all the missing factors. Well, they've already broken it down for a number of these. So we always will know that 1 and 6 are factors. Any number times 1 is itself. So every single number is going to have a factor of 1. So we then have to look at, well, 2. This is where we know our divisibility rules. 6 is an even number. So I know 2 and something else will go into 6. Well, that number is 3. All right. So let's do 16 then. Well, again, 1 and 16 will work. Every number times 1 is itself. So 16 is 16 times 1. But then I know that I'm going to have something and 8. Well, 16 is an even number. The 6 is even in the 1's place. So I look at that and I know that 2 and 8 will work. But then I see this 4. Now this 4 here is special because 4 squared, or 4 times, oh goodness, let's say 4 times 4, that is 16. So 16 is a perfect square. So a perfect square, if I were to draw out, let's see if we can draw out a nice beautiful square here. And if I were to break down our lines on this, then we would have, let's do 4 rows and 4 columns. So there are a total of a 4 by 4 grid. So there are 16 total squares in there. It's a perfect square because 4 times 4 is 16. Well, that's why you only have one 4 here in the middle. All right, so let's look at 17. Well, the only factor for 17, or factors for 17, is 1 and 17. So this is what we then call a prime number. Now, a prime number, that means that it only has 2 factors, 1 and itself. So 17, the only way we can get to 17 by multiplying 2 numbers together is 17 times 1. All right, then for 20, now we're getting more numbers here. So I've got, well, like we said, we always will have 1 in that number, so 1 and 20. And then I know it's even, so 2 and 10. And then I have 4 and 5. All of those are factors of 20. And do you see how, give yourself some space here when you start writing them out, when they don't just give you the blanks. All right. And 36, well, there's a big one. So 1 and 36, 2 and 18, 3 and 12, and then I need to fill in both of these. So, well, if I look at my numbers, counting up numerically, I will eventually get to a middle number, 4 and 9. And then 36, again, is a perfect square. 6 squared means I'm saying 6 times 6, which is 36. All right, so now we need to show all of our factors here, and they don't give us the little blanks. All right, so now we have to really think about this. So I know that I'm going to have for 8, every number is going to have 1 and 8. Give yourself some space. And then I've got, well, 8's even, so 2 will work. 2 times 4, and 3 doesn't work. And then I'm at 4. So I work my way to the middle. Then I'm done. 12. Well, I know it's going to be 1 and 12. And then I've got, well, 12 is even, so 2 times 6. And then 3 times 4. Put commas between all of our numbers here. And I'm in the middle then. So I'm done for 25. Well, 1 and 25, of course. And then, well, 2 doesn't work because it's not even. 3 doesn't work because 2 plus 5 is 7. 7 is not the multiple of 3. 4, no. 5, yeah. 5 squared. 25 is a perfect square. 5 times 5 is 25. 29. Well, 1 and 29. 2 doesn't work. 3, 2 plus 9 is 11. 11 is not a multiple of 3. 4, no, because 4 times 7 is 28. 4 times 8 is 32. 5, no, doesn't. And then 5 is 0. 4, we just did. 6, 2 and 3 didn't work. Oh, goodness. Well, 29 is prime. So that's all we have. And 30, we have 1 and 30. And it's even, so 2 and 15, 3 and 10, and 4 doesn't work. 5 ends in 5 or 0, so yep, 5 and 6. So those are all of our factors for 30. All right, explaining your own words how you know that a number is prime. Well, take a moment, think about that. We just talked about it before, so if you need to scroll up, look up just above about what we talked about, what a prime number is. But a prime number only has 2 factors, 1 and itself. All right, so let's look at our next page here. Circle all the numbers that are prime. So now we have to, break down what each of those are. And so if we are looking at this, well, 1. 1 is a unique number because it is neither prime, and if it's not prime, then we call it composite. So it's neither prime nor composite, because I can't multiply 1 by anything to get to 1. And for a number to be prime, it has to be 1 and itself. Well, 1 is itself, so it's neither prime nor composite. But if we then look at all of our numbers here, well, those prime numbers, 2, because the only 2 numbers we can get to 2 are 2, let's write that numerically, 1 and 2. 3 is prime. Oh, let's do 3 is prime because, again, each of these is going to be just 1 and itself. So 1 and 3. 4 is not prime. 5, yep, 5 is prime. 1 and 5. 6 is not prime. 7 is prime. 1 and 7. 8 is not prime because I can multiply 2 times 4 and get there. 9 is not prime because it's 3 times 3. 10, nope, 2 and 5. 11, yeah, 11's prime. 1 and 11. 12, nope, 2 and 6. 13, yes. 1 and 13. 14, no. 2 and 7. 15, no. 3 and 5. 16, no. 2 and 8. 17, yeah. 1 and 17. 18, nope, because I can multiply 2 times 9 and get to 18. 19, yeah, 19 is prime. Only two numbers to get to 19, 1 and 19. That makes it prime. 20, nope, 2 and 10. 4 and 5. 21, nope, 3 and 7. 22, nope, 2 and 11. 23, yes. Only two numbers, 1 and 23. 24, no, 24 has so many factors. It's 2 and 12, 3 and 8, 4 and 6, 1 and 24, of course. But because of those factors, it's composite. 25, nope, 5 times 5. 26, nope, 2 and 13. 27, no, 3 and 9. 28, no, 2 and 14. 29, yes. Only two numbers, 1 and 29. And 30, just like 10 and 20, they're even. It also ends in 5, but we can multiply it 5 times 6. So if it's not prime, then we call that composite. So let's talk real quick on composite. So a composite number means that we have 3 or more factors. So 3 or more factors. So if I were to look at like the number 6, well, 6 can be made up, of course, 1 and 6, but it also has 2 and 3. Now, 4 is another example of a composite number, and it has 1 and 4, but 4 is a perfect square. I could say 2 times 2, and that works. So that's why we have our 3 factors, and that makes it composite. So choose one of the prime numbers circle, explain how you know that it was prime. We just talked through that. So really, let's simply leave our notes to say that the only even prime number is, and if you look at that chart, the only even prime number is 2. Because every other even number, I could use 2 as a factor for it. That's kind of a big indicator and way to remember prime versus composite. All right, so those are our notes after watching our FlowCAD video. Hopefully this helps, and let me know if you have any questions.